Alright, so welcome back. So in the previous tutorial, we saw how to do sentiment analysis in Rust, which is still part of the NLP in Rust. Let's see how to do some other wonderful stuff with a very nice library called Natural for tokenization, Ngrams, Phonetics, and then sentiment analysis again, right? Or text classification. Let's go to text classification. How do you do that using Natural in Rust? So I'll go back again to our workspace here, which is here, and we're already inside this location, and this is what we were doing previously. So let's go back again, and then we add a library. So the library is going to be cargo add natural. So natural is a very nice library that allows you to be able to do some very cool NLP tasks. So let's import it from top. So I'm going to go back here. This is natural, right? So you can use it to do text classification, or I can just go with the use natural, then we can just import everything, right? But let's see use natural. I want to see the first thing we can do with it. We can do tokenization, right? So tokenization is a very important thing. So how do we use natural to tokenize the test? In case I have some tests there, I can just call it as example 1. So let example 1 be equal to my test. So a wonderful test, right? And I want to tokenize this. I can simply do this. I can use the tokenize library, then I'll just pass in my test, right? So example 1, and this is going to tokenize the entire stuff for us. So now I can print this one out. So let's save this one into a variable. So let's result, then this is going to be a vector, right? And then I can just print it out. So print line. I can just go back here, because it's a vector. I'll just pass in my result. So this is a simple stuff you can do with natural. So cargo run -kill. Right, so this is going to tokenize this test and give us a result. So this is being done by the library. You can also write your own function, custom function, to help you do that. So a simple example of a function that I can run to help us with this is, you can just create a function. Let's create a function here, first, then custom tokenizer, right? Then I'll just pass in my test. There are several ways you can do that. My string, and this string is going to return a vector of strings. Then I'll just go back again, and now let's pass in my test here. So it's still taking some time, and then I can just return. So the test that I have, I can convert it to lowercase, then I can convert to lowercase, then I'll split. We have ASCII white space or just white space, and then this is going to return a collection, right? So I can just map it, then convert this, use a closure, then I'll just convert it to string to get the entire stuff into a string form. Yeah, that is it, right? And then I'll just go with the collect. Perfect. So this is a simple function that is also going to do exactly the same thing that we have above, right? So it's taking forever to run. I hope I have space. Yeah, I still have some space. It always takes a lot of time, right? Let's stop it. So cargo clean. Yeah, and then let's run it again. Now it's going to compile it, right? So this is another way. So either use natural tokenize to help you do the tokenization, right? That is a simple way you can do that, and then we can just pass it there. Now we can also do some stuff like Ngrams. So in case you want to get the Ngram from a particular test, you can also use natural to help you do the same thing, which is a very nice library to do that. So all you need is you just have to import from the top. And then you just go with my Ngram, then you just go with get Ngram. So we have get Ngram with padding, get Ngram, just like that. And then you just come down here, then to the particular test that you want, you can just simply get the Ngram, right? So it can be something like let's example 2 be equal to some text that you want to get ngram of. So get ngram, then you just pass in the text. So I can pass in another text here, or I can just pass in this example 1, right? And then this is going to be the number that I want. So I want maybe 2 ngrams, 2. So I'm going to split them into 2 ngrams, right? Then I can print this one out. I hope my system does not crash. Then I'll just pass in my example 2, right? So this is another way you can also do the ngrams. So you have seen how to do tokenization, how to do a simple ngram. We can also do some phonetics with this library. And then to do simple phonetics, we can just go with something like, have to import it from the top. Phonetics is when you're trying to find how something sounds, and then you can simply do it in this approach. Right, so sound this, and then the sound this. So now it took some time. We got this is a wonderful test tokenize, this is a wonderful test, right? Tokenize. As you can see from here, I can run the other ones. So let's save this one and run the other one. So the kill to get the tokenize, and then to get the ngram, right? So with the phonetics, all you do is just get the word that you want. So let's say let t1 be equal to some term. So we have the sound text word, which you create a simple instance of it. So let's call it as, let's say C, right? Or let's say meat. And then yeah, you could see that the tokenize worked perfectly well. The ngram, because he specified 2, is splitted them into 2, right? This is a wonderful test, right? So this is a very nice tool that can be used in NLP tasks. Now let's see the sound test. So I can just say this is meat, then I'll create another one for S2 or T2, then I'll call it as meat, right? So we are 2 meat. And then in case I want to check the phonetics of this, I can just go with T1, right? Or T1 dot sounds like, then I'll pass in T2, right? So something like this. So I can now check if it sounds like that one way or the other, right? So we can assert this. Let's assert equal to make it give us true or false, right? Yeah. Oh yeah, let's know, not just assert equal, just assert, because you're not certain. Perfect. So let's go back here, and then let's try it out. It not give us any result, but we can print the result. So print line. We can use debug, right? You know, you can use debug. Yeah. Let's take off this. Then let's go. Then I can just write again. So now it is true, right? It sounds alike, right? Meat and meat sounds alike. But if I say meta, it will give us false. It also sounds similar. That is interesting. I think it's using meta and meat is funny. So let's say mecha. Something like this. And it's false, right? It doesn't sound alike. So this is some stuff you can do. So we can see how we can do ngrams, we can do phonetics. Let's see, how do you do test classification with this library? So test classification. So to do one, we can simply have a test with the test classification, which is going to be very simple. We already imported the naive base from here, And then once we import the naive base, we can just create an instance. So let's create my model. So let model be equal to my naive base. Let's call this, okay, let's mutable naive base model, right? Let's go to the naive base, create an instance of it, and then we use it for our test. So this is the first, you create your model, then you train, right? It's very simple, and then you predict, right? So you have the naive base model, you now pass in some tests. So let's say nbc dot train. I can pass in some text in the classification, so it must be a string and a string. So I can now just go back again and say positive, right? So I can use this one for sentiment analysis, as I said. So I can say, man, this is so cool, and I'm going to call this one as positive. It's going to be positive, right? So this is how to train it. You can add to string to it, but you know that it's taking string slice, so it can pick all of them. Then I'll try again for the next one, third, fourth. So this is so cool. This should work well. It's positive. Always make it random, right? So this, and let's say I don't like it. This will be negative. And another one. This will not work. Right, and then I'll pass it as negative. Now, so this is it, and now I can predict. So this is going to train and store everything, and I can now predict. So nbc dot, we don't call it predict, it is called guess, right? So it is just guessing. Now passing another test. So this works, right? This works, something like that. I want to see what it's going to give to us, and I can put the score somewhere, right? So let's do print line. I hope it implemented. Then I can just pass it in, right? Yeah, print line. Perfect. So let's run it. And now we see that we got negative, right? This is quite interesting. You notice that we got negative for this works, because I think because we have some words that are similar. This is okay, but it's not the best. You need more data, right, to be able to train it. So these are some of the tools we can do with the library called Natural. You can do tokenization, Ngrams, Phonetics, text classification. So in another tutorial, we'll see how to use some of these tools to build an actual model, right? So thank you for watching the tutorial. See you another time. In the next session, we're trying to see how to build this app. Stay blessed.